Okay, so this is the answers to the algebra practice test. Let's go through them and let's see the methods. All right, so the first question. So remember, when you're solving equations, each step must have two parts, do the opposite, and then balance the equations. So I want to get rid of this -4. So to get rid of it, I do the opposite. I add 4 and balance by doing it to both sides of the equation, or both sides of this equal sign. It's like a balance point. -4 plus 4 disappears, and I'm left with just x on this side. X equals then 10 plus 4, which is 14. Of course, you can always check your answer at any stage by putting x back in. Is this unknown? 14. 14 take away 4 is 10. Okay, it works. Yay. So that is correct. Second question. I want x on its own. 2 is added to it. 3 is multiplied by it, so I must do the opposite of those two. If I subtract 2, I have no longer 2 added to it. Do that to both sides. That's disappeared. 3x is still on this side. 3x is 14, take away 2 is 12. So 3 times x is 12. So you probably know the answer, but do the opposite thing to find out what it is for sure. Dividing by 3. X is then 12 divided by 3, which is 4. All right, so 4 marks for that question. That's 2 each. And for the method, not for the answer. So if you've done a method and got the right answer, you will get 4 out of 4. All right, simplifying equations. Okay, so simplifying, be adding or subtracting any like terms. So I have an 2a and a -4a. I can rewrite that if I want, 2a minus 4a. That gives me, well, 2 of something, take away 4 of something. I must go into the negatives. I go to -2a. And 5 plus 12, I can rewrite that separately if I want, and it's 17. So, what's my answer? I didn't need this working out. I can get the answer straight away here. Notice there is no show methods or show answer, because you can just do it from looking at it. -2a plus 17.
Mr. Collins?
Yeah.
Does it count if it's 17 minus 2a or no?
No, yeah, 17 minus 2a is same thing, yeah. Yep. Same thing, full marks. Order doesn't matter here. All right. This one, 8x and 2x are a like term. So I'm not going to show the working out for this. I'm just going to go straight to the answer. 10x's, 8x and 2x. 5xy has nobody. So he or she's on its own. So 5xy doesn't have any friends. Use the pattern to create a formula. Okay, so first of all, create a table. All right, what do we need for a table? We're going to call it shape, number, and matchsticks. So each one of these is a matchstick. Each one of these little lines. So the first shape, x, when x is 1, how many matches does that have? Oh, we can start to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 matches. All right, you can do the same for the second shape. So I'm creating a table here. I have 3 shapes. I think the next one has 19, and the next one has 26, but you could have just counted them. That's the table. 2 marks for that. What's the rule of this pattern? So what's the rule is what's added or subtracted each time in this case. So many matches are added each time. So I'm noticing patterns here. So an increase of 7 matches each time. So what's the rule? Add 7. Or add 7 matchsticks or something like that. It's just whatever you're adding. Okay? So hopefully you now know. Okay. It's just whatever you're adding each time. This adding bit tells me something about the formula of the pattern. If I need to continually add 7, add another 7, add another 7, that means I must have to multiply by 7 when I'm creating a formula. They're dealing with multiples of 7, some pattern of a multiple of 7. So 7 times x is going to be in the formula. Y equals. Okay. So there's 2 ways I can go about getting my add or subtract here at the end. I can test my formula and see how far away I am. So 7 times 3, does it give 26? No, it's 21. So I'm 5 off, I think. 2 times 7 gives 14, not 19. So every time I'm 5 off. Or you can go 1 back to the 0 pattern. 1 before all this by subtracting 7, and you end up with 5. Either way, adding 5 additional matches must be done. All right. Let's move along. 2 marks for each of those. Question 4. Evaluate the following when x is... So this is a substitution question, but I must show my workings. Okay, so I can't just get straight to the answer. So do show your workings for this. So that would have to show your substitution. So x is 3, so I'm going to make that 3. Y is 7, so I'm going to make that 7. Plus, and y is 7 again. I can put that. Okay, so something like that. You can use multiplication signs there if you want. Probably not brilliant when algebra to use a multiplication sign because it does look like a lot like an x. All right, this is a multiplication. 3 times 3 is 9. 9 times 7, 63. Add 7 then. So 63 is 70. This one, x, take away 2y. X is 3. So, and minus 2y is 2 times. So 3 is okay. Don't need to do anything with it. Take away then 2 times 7, 14. Or just minus 14. So 3 take away 14. So you need to go into the negatives. Negative 11. Fully factorized. So factorizing is the opposite to expanding. So we have expanding down here, and factorizing is the opposite. We need to put in brackets. So anytime you see a factorizing question, you need to put in brackets. We didn't have one yet. Okay. So I put in brackets. I know there's going to be brackets. I know there's going to be 2 terms in the brackets. I know they're going to be separated by a plus. I can do that if I want before I start. Now I need to pick, is there any number that divides into both of these? Well, yeah, 5 divides into this and this. Okay, so 5 is outside. Is there any letter that goes into both of them, that is present in both of them? Yes. X is here and X is there, so X is outside. Okay, what's left behind? Well, 5x times what gives 10x squared? Well, 5 times, it has to be 2 anyway, to give 10x squared. So it's like you're dividing 10x squared by 5x. And what else? So 5x times 2 is only going to be 10x, not 10x squared. So I need to have an x here to make x squared. What's left behind this one? Well, 5x is already divided out of that, so we're just left with a y. And that's it. Can't do any more. That is it factorized, fully factorized. So if you only took out the number or only took out the letter, that'll only be half marks because they're asking to fully factorize. So you need the highest common factor to both. So the highest common factor to both is 5x. All right, this second one. Once again, I'm just going to start with my brackets. And I already put a plus in between. I can do that if I want. Common to both. 1, obviously. 2, thinking of a number here, but 4 is the highest common factor. All right, 4. Is there a letter common to both? Well, no. One is A and the other is B, so I can't take the same thing out of both of them. So there is no letter in common to both. So what's left behind? 4 times what gives 4A? So it must be A. 4 times what gives 2? Gives B. 8B. It must be 2B. 4 times 2 is 8. And that's it. Next one. Simplify. So that's the opposite thing. So we've got to multiply these out. So using distributive rules. So 2 times both these things. So that's going to be 2x plus 6 plus 3x. That's it expanded. Now I want to simplify fully. So add any like terms. 2x plus 3x gives 5x's. So that's those two added together, and I have a plus 6. That's it. Can't solve. You notice the way in all these questions so far, except for question 1, there's no equal sign. So I can't solve it. I can't get it to equal anything. I'm not trying to find x. I'm just trying to manipulate algebra, it's called. Like moving things around, multiplying, dividing, factorizing, expanding. Just moving and manipulating algebra, which is a key skill all the way up to year 13. this one. Okay, once again, multiply by 4 first. 4 times a is 4a. 4 times minus 2b is minus 8b. Looks a bit like that one up there. So that was a little bit of a hint if you weren't sure. Plus 2 now times a squared. So 2 times a squared, that's going to be 2a squared. And 2 times b is going to be 2b. Okay, that's it expanded. Now I have to simplify, add any like terms. Now once again, it doesn't matter what order I do this in. I can write the 2a squared first if I want. That's one. Is that the same as 4a? Is that? No, they cannot be combined. So just plus 4a. And then negative 8b plus 2b. Now they are like terms, so they can be combined. So 2b take away 8b's, that's going to be minus 6b. Okay. Question 7. Create the formula for each of these. All right, so we had this question before in one of our classes, but I'll run through it again here. This table could be written another way. So the first, second, fifth, sixth, and 10th term is there. So if we wanted to redo this table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could have, let's say they were shape numbers and matches. There's 10, but they're not giving us all the information. They're only giving us certain bits of it. They're giving us the first term is 6, first term is 1, the second term is 6, and then they skip out terms 3 and 4, and they just give us 5 is 21, 6 is 26, and then they skip 7, 8, and 9. They give me 40, the last term as well. Okay, so they've skipped some terms. They just have only given a few. So you can redraw the table as this if you want. Now, we could create a rule here because we have ones beside each other. That's plus 5 here. That's also plus 5 here. And just to confirm, if I added 5 here, I would get 11. If I add 5 again, I would get 16. And if I added 5 again, I get 21. So adding 5 seems to be my rule. As soon as I know my rule, I can jump straight to my formula. Now, you do not need to redraw the table like this. We could have noticed that up here. That's the first, these terms are beside each other. There's only going to be one jump, so that's just plus 5. You're adding 5 or whatever it is. And same here, from 5 to 6 is a jump of plus 5. All right, so that means if it's adding 5 in my rule, it must be multiplying by 5 in my formula. So G equals, bottom line is equals 5 times S. So that looks like 2 5s. Okay, that's a terrible S. 5, that's a 5S. I need to figure out plus or minus. Yeah, I'll try not to use S in the exam. Otherwise, we could have a lot of complicated looking 5s and S's and stuff. So we need to figure out what we need to add. So we can just test one of these out. 2 times 5 is 10, not 6. 5 times 5 is 25, not 21. So we're always 4 away. So we're too high. So we need to subtract 4. Test out for another one. Let's just do it for this one. So 5 times 10 is 50. Take away 4 gives 46. So it does work for that. Lily, yeah, I definitely prefer if you wrote it number then letter. It's just the algebraic way things should be done. Or I will accept 5 times S minus 4 if you want. And I will accept S5, but that really is a poor way of writing algebra. I wouldn't try and do that. Yeah. I'll give you the marks, but don't try always put the number. So if you've got a choice and you've got A times B times 5 times C, that was something you had to multiply by each other. Well, multiplying would just shove them together, wouldn't it, of course? So it would just be AB5, but we wouldn't write it AB5C. We'd write it 5ABC, like that. The order does alphabetical and number first. For D11. All right, let's move on. So now back to solving equations. Okay, so expanding first will help with this one. 2 times x gives 2x. 2 times -5 gives -10, and that equals 10. All right, so that's step 1, remove the brackets. Step 2, let's do the same as we did in question 1, do the opposite. So if I want to get rid of a -10, I add 10 to both sides of the equal sign. That will disappear. 2x is left behind. 10 plus 10 is 20. Divide both sides by 2 to get rid of 2 times x, and x will be 10. Second question. Multiply both sides by 5 to get rid of the 5. I cannot subtract 2 because it's attached to this 5. I'd have to subtract 2 over 5. And I don't want to do that. That's awkward to do fractions. So multiplying by 5 both sides will remove that 5 from the left. X plus 2 is here. 6 times 5 is 30. Okay. Subtract 2 both sides. I want to get rid of that 2. And x is 28. So if x is 28, I'm not sure about that. Is that a right answer? Let's check. You don't have to check, but I'm just going to check for one of these. So I'm going to replace this x with 28. It's going to be 28 instead of x. Plus 2 divided by 5 is 6. Does this work? 28 plus 2 is 30. 30 divided by 5 is 6. So it does work. So that answer is correct. So I can always check any stage. Next question. Right, so the x is on the right-hand side of the equals. That's okay. I need to get rid of -7 here and -3. Getting rid of the -7, add 7. Draw. Okay, that's gone. 6 plus 7 is 13, minus 3x. So I need now to divide by -3, because that's -3 times x. So if I do the opposite thing, I want to divide by -3. Both sides. So my answer is 13 divided by -3. So you can leave it like that if you want. It's a negative fraction, so it's -13 thirds. Or you can say -4.3 recurring or something like that. Either is fine. Okay, so substitution of negative numbers in the last question. All right. Replace them first, so actually substitute them in. That's that done. X is -3, y is -5. Let's do any multiplications here. 3 times -3 is -9. Plus 5 times -5. Well, you can go plus -25 if you want, or you can just write in -25 because a minus and a plus is a minus. So it's -9, take away 25. So we go further into the negatives. You end up at -34. 9 further into the negatives. 10 further into the negatives, of course, would be -35. So it's just one less. Okay, this one. So we got -3 squared minus 2 times -5. A lot of minuses going on here. -3 squared. Now that's -3 times -3. So I could rewrite that -3 -3 by itself twice. Okay, I've just put in an extra line to show that. Minus times a minus is a plus. 3 times 3 is 9. So that's actually +9. So you notice that a negative number squared is a positive number because a minus times a minus is a plus. And -2 times -5, another minus times a minus. That's going to be plus 2 times 5, which is 10. Answer 9 plus 10, which is 19. All right, moving to the last page. Fully factorize the following. So we need, once again, the highest common factor for both of these. So what's the number that these two numbers have in common? I think 3 factorizes out, so I could have drawn my brackets first, but I actually just take out 3 for a second. I'll draw my brackets after I figure out what I had -9 plus 10. Yeah, So minus a minus times a minus, so minus 3 squared is a minus times a minus. So it's got to be a positive. Negative times a negative. Okay. Common letter is x, so that's 3x taken out. So what's left behind from this? Well, to make it 3x squared, I need an x in the brackets. Minus here, 18, well that's 6 times 3, so 6. One of the x is gone, and we're just left with y squared. So it should be 3x times x minus 6y squared. Next one caused a few interesting difficulties. What's common to both these? Well, 4 is. That's the only thing. What's left behind? Well, 4 times a, that's okay. What do we put when it's just 4? How do we make it again? Well, remember, this has got to multiply back to give that. So if I put 0 here, I'd get nothing. Because 4 times 0 is 0. So it has to be 1. Because 4 times a gives 4a, and 4 times 1 gives 4. All right. Question 11, type your answers in the chat. Let's see if anyone got them. Already got 1.76 for question 11. Anyone else get an answer for question 11? There's minus 35 over 13. There's, yeah.
No, like the whole thing's a minus, not just
the whole thing's a minus, yeah. Well, yeah, once one part of the fraction, we got 20, we got minus 6 as well. Okay, let's have
That's what I meant.
All right. So first of all, I would remove the brackets. So 2 times both these. So that's 2x minus 6, and now minus 5 times both these. Minus 15x minus 15. And minus 5 times a plus 3 is minus 15. Okay, equals 14. Right, I'm going to add or subtract like terms on the same side first. If they're on the same side, you add or subtract them before you start solving. So 2x take away 15x's gives me negative 13x. Okay, some of you guys looking like you might have the right answer. Negative 13x. Minus 6 take away another 15 is negative 21, and that equals 14. All right, solve. So I need to get rid of a negative 21, so I add 21. And that's going to make negative 13x equals positive 35. Oh, here we are now. Divide both sides by negative 13. And I think we have our answer as x is 35 over negative 13, or it's just a negative fraction. So it doesn't matter where the negative is. If one part of it is negative, the whole thing is negative. Because remember, if both parts are negative, it turns positive. That's our answer. So, yeah. Cleo, Lana, Elan, you all got it right. Reese, you got it right. Yeah. Well done. Tricky one. All right. 2 questions left. Question 12. Evaluate the following. So, once again, we got some negative numbers. We got squaring. Oh, I imagine if you got the other one wrong with a square of a negative number, you're going to get this wrong as well. Well, let's start off. Replace x, y, and z with brackets, and it's equivalent here. So x is negative 3, so negative 3 times y times z times negative 5 times 2. Type your answer in the chat for this one too. Let's see if anyone got it. Minus x squared, so that's minus 3 squared, so that's minus 3 squared again. All divided by 2xz, so 2 times negative 3 times z, which is 2. And then I'm going to subtract, after I deal with all this, I'm going to subtract 7 times negative 3. Oh my goodness, there's a lot of negatives. All right, so 77 over 4, a few people got, okay. So we know what x is, Reese, so you shouldn't have an x in the answer. All right, let's combine what we do know. Minus 3 times minus 5 here at the top. I'm going to try and turn this into just one fraction instead of a big mess of a fraction. Minus 5 times minus 3 is 15. Positive 15. Positive 15 times 2 is 30. So I'm just going to put that underneath 30. Minus 3 squared now is minus 3 times minus 3 for the same reason up here. And that's 9. So that's take away 9. Okay. On the bottom of the fraction, 2 times negative 3 times 2. Yeah, the recording will be in the chat or in the messages later. 2 times is that's minus 12 times 2, which is minus, just minus 12, isn't it? Minus 12. 2 times 3 is 6. 6 times 2 is negative 2. Okay. This fraction, I'm just going to work it out before I take away this bit. And so 30 minus 9 is 21. So that's 21 over minus 12. I can simplify that actually. If I want to, I can use my calculator to divide, but I'm going to simplify it. I'm going to use my calculator. 3 goes into the top and the bottom. So that's actually 7 over 4, 7 over minus 4. Okay. Now, I'm going to now take away. So multiplication must be done before any adding and subtracting. So I got to multiply minus 7 times minus 3. Minus 7 times minus 3 is positive 21. So I still have that, plus 21. All right, common denominator of 4. So that's going to have to multiply by 4 over 4, which gives me 7 over minus 4 plus this over 4 is, multiplying that by 4 is 84. Okay, now combining these all over 4. So it's minus 7 plus 84. Doesn't matter, well, I suppose it does. I've used 4 as a common denominator positive, so the top of the fraction is, the whole thing is negative, but the top of the fraction is where you really should keep the negative with. And that will give 77 over 4. So you got us. Okay. So minus 7 over 4 was the tricky bit to get that. Question?
Can you simplify it into a mixed fraction?
Sorry?
Could you simplify that to a mixed fraction?
Yeah, if you want, yeah. Well, 4 into, if you want to divide it in, 4 into 77. 4 into 7 goes once, carry the 3. 4 into 37 goes, I think, 9 times. Carry the, or we don't need to carry the 1. What's the remainder then? It's 1. So it's 19 and 1 quarter, I think. Okay. All right, last question. All right, there won't be the question in the actual exam won't be as vague as this one. This is quite vague. It'll be more straightforward. It'll be getting an answer for something. All right, but Ben says that 4x squared over 2x equals 2x. And Emma says that's not correct if x is 0. All right, so what happens when x is 0? 4 times 0 squared, I suppose, if you want to just sub it in, it's 2 times 0. And that Ben is saying is 2 times 0. Now, this gets complicated. 0 squared is 0, 4 times 0 is 0, so this is actually 0 over 0. Okay. Is that the same as 0? 2 times 0? I suppose no. It's not. In maths, the term 0 over 0 is something that's called indeterminate. Oh, spelled it wrong. Oh, spelled it again. Okay. Indeterminate kind of means that, if you divide something by 0, or if a number divides by 0, that doesn't really work because the opposite multiplication should then work. If something divides by 0, then the opposite multiplication should work. Multiplying by 0 should give the same answer out. And anytime you get in maths 0 out of 0, it's called indeterminate form, as in it's not a legitimate answer. So does this work for other numbers other than 0? Let's try your 1. 4x squared over 2 times 1 equals 2 times 1. So I've just tried 1 here. So that's 1 squared is 4. 4 over 2 is 2. 2 equals 2. So it does work for 1. Does it work for 2? 4 times 2 squared over 2 times 2 is 2 times 2. So what's 2 squared? Not a number for, yeah, so type it into your calculator. Some calculators are different than others. I'll do it. So 0 divided by 0. My calculator. Hold on, I showed the last screen, didn't I?
Even if you ask Siri, it's hilarious.
Yeah. So you can check on your calculator, but 0 divided by 0 is not a legitimate operation because it would suggest that the opposite then is true. 0 times 0 is 0, and 0 times 0 is 0. But anyway, this won't be a test question, something like this. It'd be more straightforward. I just thought I'd throw it in there just to see what you would come up with. Yeah. But does it work for this? We'll check again. 2 squared is 4. 4 times 4 is 16, divided by 2 times 2, which is 4. So 16 divided by 4 is 4, and that also equals 4. So it does work for everything, and you can kind of prove that using algebra as well, because 4x squared is 2x times 2x, if I factorize it, and dividing it by 2x, well, that goes into that once, and we're left over with 2x, which of course equals 2x. So it does work for every other number other than 0, because 0 over 0 in your calculator gives you indeterminate or error, or it's a mess. But that was just a kind of a trick question at the end, just to get you thinking. The one in the exam is a lot more straightforward. Okay. So